Hello everyone and welcome to task number 7. In this task, we are going to train a linear learner model using SageMaker. If you guys remember from the previous task, task number 6, we have been able to evaluate our trained model performance. And please note that from the beginning, we haven't even touched any of the SageMaker built-in algorithms. So now we're pretty much ready to go ahead and get started. Okay, so first, we need to import SageMaker and we need to import Boto 3 as well. Boto 3 is the AWS Software Development Kit or SDK for Python. Simply put, you can use Boto 3 to interface with services from AWS, such as S3 and EC2, for example. Okay, it will make our life 10 times easier. So we need to import these two first, and then we are going to create a SageMaker session. So we're going to say SageMaker.session, and that here will create my session. And basically, I'm going to refer to this session later on when I actually train my model. So if you actually scroll down here, you will find that SageMaker session is being called in here when I actually train my model in this section. I'm going to come to that later. I just wanted to show you where I'm going to use that session. Okay. All right. And then what we're going to do here is that we need to define where we are going to store our training data. So when we train a linear learner or any built-in algorithm within SageMaker, we need to make sure that our data is contained in S3. And what we're going to do when the model is trained, we are going to store the model artifact in S3 as well. So we need to specify the path for both the training data and for the output or the model output. Okay. So first, I need to create a bucket, and this bucket here, I call it SageMaker Practical. Okay. So I actually created that bucket already. So let's go ahead and see how can we do that. If we go back to S3 here, okay. If you go to services, if you can go to S3, okay. So here it will open S3. And here I have a bucket that's already called SageMaker Practical. If you want to create a bucket, you can just come here, say create bucket. You can call whatever bucket you want. For example, I'm going to call it SageMaker Practical. Let's say 2, for example. Please note that I already have mine, and just, I don't want to overwrite it. So I'm just going to call SageMaker Practical 2, for instance. And here you can provide the region. So here I'm going to call it in US East 2 in Ohio. I'm going to say create bucket, and that will simply take care of it. So now I have a bucket that has been created, and here I have these two buckets that I have. Okay, so please note that I'm going to be in this bucket. I'm going to create basically what we call it prefix or subfolders within my bucket, and I'm going to specify the training data location and the output as well, location 2 for my trained model. So here's my bucket. So I've created a bucket, looks good. The second step, I need to define my prefix. So the prefix is simply the subfolder within the bucket. And the prefix here, the next step is that I need to basically obtain my role. So role will be equals to SageMaker dot get execution role. If you guys remember, when we try to access any resources within AWS, we need to make sure that we have what we call the identity and access management or IAM role. That will grant or deny basically users permissions. And it's very important here to make sure that the IAM is set properly. So if you guys remember, when we created the notebook before, we specified an IAM role for it. So here we say, okay, let's get the execution role for that notebook instance. And I'm going to take that role and actually pass it along when I train my model. So actually when I come here, I need to specify the role. Okay, so basically I need to specify my session and I need to specify my role as well. Okay. So what I'm doing is just I'm getting the role. So I'm going to say role equal to SageMaker dot get execution role. And I'm going to print the role as well. Let's press Shift Enter. Here we go. And here's my role. So my role is called Amazon SageMaker execution role. and this is the ID for my row. Okay, all right. Let's go ahead and check out the shape of the training data. So I have 26 by 1. And here, what I'm going to do is I'm going to check out the white train as well. So that's my white train. Let's take a look at white train right now. And my white train is 26. Okay, so I have basically just one vector output, and that will be pretty much ready to be fed to my SageMaker linear learner. Okay. The next step is I wanted to basically here, these lines of code are primarily used to convert my training data into a record I/O format. If you guys recall from the linear learner, actually I have it open here. So this is the linear learner algorithm. So here I have everything related to the linear learner. So if you actually open linear learner algorithm, you will find a ton of details. So it's telling you what the linear learner is, can be used for classification, can be used for regression. And here it can be used as well. Here are the different metrics. For example, if you're doing regression, we want to make sure that we can use mean squared error, cross entropy, or absolute error. If you're doing classification, you can specify precision, recall, or accuracy. And if you go down here, you will find all the information related to it. I really like the documentation from AWS. It's extremely detailed. And you can check out, for example, the input-output interface. So you need to make sure that you're following here the instructions. So it's telling you, for example, for training, the linear learner algorithm supports the record I/O protobuf format and CSV format. And that's why when we train our model, we want to make sure that we are following that format. So first, we're going to import I/O, and the I/O module allows you to deal with various types of inputs and output data, such as text I/O, binary input/output, and raw I/O data as well. We're going to import NumPy. Actually, we had imported it before, so we don't need to repeat it again. And then we are going to use the SageMaker Commons library to do the conversion for us. We call this SMAC. Okay, so it's called import SageMaker.amazon.common as SMAC, and you can refer to that SMAC to do the conversion for us. Okay. So this code below, these 3 lines of code are very simple. They just convert the data in NumPy array format, or from NumPy array format to record I/O format. Okay. So first, I need to define a buffer. Think of this as an in-memory byte array. Okay. So I'm gonna say buff equals to I/O, which is I imported before, dot bytes I/O. Okay. And this is basically the buffer that I will be writing to it all my training data. So I'm gonna use a SMAC that I imported before, the SMAC library. And then I'm going to use write NumPy to dense tensor. Okay, I know it sounds a little bit weird, but again, it's very simple and very straightforward. All what we're doing right now is just trying to get the data to be in a format that is accepted by SageMaker Linear Learner. It's all what it is. So I'm going to say a smac.write NumPy to dense tensor. We're going to feed it in here my buffer, and I'm going to feed it in my X train and my Y train, which is my input and output data. And then when we write to this in-memory byte, you will find that there is a counter that basically keeps counting or incrementing by 1 every time you write to it. So we have to make sure that we actually reset that counter at the end. So that's why I'm going to say buff.seek of 0, and that will reset the counter for us. Okay, so let's press Shift Enter, and here we go. We're good to go. And now I basically have my data right now, and the data has been converted into a record I/O format. And please note the data is contained here within the buff right now. Okay, so what I need to do right now is I need to upload my data to S3. Again, when I apply linear learner, I need to store my data in S3, and then the linear learner will capture the data from there. So first, I need to define my key, and think of this as follows. When we define any information within S3, first we start with a bucket. So I have the bucket name, followed by a prefix. Again, think of a prefix as a subfolder. So it's a subfolder inside my bucket. And then I'm going to have the key, which is again the name of my file in there, which is what we call linear train data. So here I'm going to store my training data. Okay. So that's my key. It's called linear train data. You guys can call it whatever you want. And now I'm pretty much ready to upload my data to S3. So I'm going to use boto3.resource. I'm going to specify that I'm talking to Amazon S3. I need to specify the name of the bucket. So the name of the bucket here is the name that I defined it earlier, which is SageMaker Practical. And please note that I created the bucket already here, which is SageMaker Practical. Okay. And then, let's keep going. I need to specify where I'm going to be storing my training data. So I'm going to say, okay, please go ahead, use os.path.join. So I'm joining all this information in here. So I'm joining the prefix, which is my subfolder, if you guys remember. Here is my prefix, which is linear learner. So I'm feeding in, again, I have my bucket originally, followed by the prefix. And then I'm going to create a folder called train. And then I'm going to attach my key, which is linear train data. And then to that, I'm going to upload my buffer, which is my record IO data that I converted here. Okay. I know it sounds a little bit confusing at first, but don't worry. It's actually very, very simple. It's pretty much standard code you guys were going to use pretty much in most of our case studies. So now I basically uploaded my data. So let's go ahead and actually print out the training data location. So here I'm saying, okay, this is my training data location. I'll call it S3 train data. And here is my location. Again, I attached the bucket first. So the bucket will go here. So here I have my bucket. So first I have S3, okay, the first thing I have my bucket, which is what I have here. And then I have my prefix. So here is the bucket. Here is the prefix. And then I created, again, a folder called train. And then within the train, I have my key, which is what I have here, linear train data. And then I can go ahead and print that information. Let's shift enter, and here we go. So the training data has been uploaded to that location. S3, I have SageMaker Practical, my bucket, linear learner, my prefix. I have my train, which is I created here. And then I have my linear train data. Let's go ahead and see if that actually works or not. If you go back to SageMaker Practical, click on it. Okay, so that's the name of the bucket. You will find that there is a linear learner. That's a good sign. Okay, click on it. You will find that there is train. That's good. Click on it. And now I have linear train data. That's good. And there is size associated with it. So it looks like there is something has been uploaded to it. If you click on it, and here we go. So I have my data. I can actually download my data. Looks good. So now I'm pretty much ready to actually perform the training. Okay. All right, let's go ahead and check out the shapes of the testing data. So here I have my X test. Here I have my Y test. Here I have, make sure that the target label is in a vector format. So I'm going to take my Y test and just take all and 0. So that will convert my X test into a vector format. Let's run it. Okay, if I actually check out the Y test dot shape, here we go. So now I have basically the Y test is in a vector format. If you actually check out Y test now, shift enter, here. The next step is that we want to specify the location in S3 that I'm going to generate or write my model artifact, my train model. So what I'm going to do is I'm going to go to S3. I'm going to define my bucket, which is what I have here. I'm going to be written here. And then within the prefix as well, so bucket and prefix, if you guys remember, I have my bucket, SageMaker Practical, and then I have linear learner, that's my prefix, okay? And what I could do afterwards, let's go down here, is that I'm going to create a location, and that's what we call it output, and that's where I'm going to store my output data, okay? So here I'm just going to print basically the output location, shift enter, here we go. So now I have in S3, I have SageMaker Practical, and then I have the linear learner, okay? And then I have the output, and that will be the output location. All right, so now we have specified the output location, okay? That's where I'm going to store my model, my train model artifacts. And the next step is that we need to obtain simply a reference to the linear learner container image. It's actually very, very simple and very straightforward. What we need to do, now we have the algorithm, it's already being built by AWS. All what we need to do is to get a reference to that container image, and then what we're going to do is we're going to feed it in or pass it along my training data, and the model will be trained. It's very simple and very straightforward. So the code that we have here is primarily used to get the training container of SageMaker built-in algorithm, which is specifically my linear learner. All what we need to do is to simply specify the name of the algorithm, and that will take care of everything for us. Okay? So we're going to say from SageMaker.amazon.amazon estimator. And please note that all regression models in SageMaker we call them estimators, and that's where the name estimator comes into play. And then we're going to import get image URI. So we're going to say, okay, my container now equals to get me my image, okay? And here, I actually don't need to hard code my region. I can simply obtain the region name from my session, from my current session, by leveraging boto3. Okay, you can say boto3.session.region name. So here I'm getting the region name, and here I'm obtaining basically the linear learner algorithm. I'm going to show you guys when we try to leverage some more advanced algorithms, such as maybe XGBoost, or maybe like PCA or principal component analysis. You will find that we're going to pretty much follow the same idea here, the same structure. We're going to simply obtain our container image, and we specify the name of the algorithm. That's all what it is. They made it really easy. Shift enter, looks great. And now I'm pretty much ready to simply pass to the container our type of instance that we would like to use. We want to pass to it the role, and we want to pass to it the SageMaker session. So we're going to say, okay, please go ahead, take my SageMaker.estimator. I need to specify first my container. So now I have my container that I obtained before here, which is my linear learner. I need to specify my role, which is, if you guys remember, I got the role here before. So here I have my role. Okay, so this is my role, as you guys can see here. Okay, that's good. And then I need to specify the train instance count, how many training instances you're looking at. I only want to use one. You need to specify the type of the training instance. And here I'm going to use c4.xlarge. Please go ahead, use whatever you want. You can use T2 if you want. Again, it's very, very simple data and very simple algorithm as well. You can go here to the output location. I need to specify the location where I'm going to store my trained model artifacts. And I've actually provided that here, which is my output location. So now I specified my output location. And I need to call as well my SageMaker session, which is what I defined before. So here I have my SageMaker session, if you guys remember. Okay, that's the session that I created in here. So that's it. That's pretty much it. It's very simple, very straightforward. And now, before I actually fit my model to the training data, I need to make sure that I properly set my hyperparameters. Okay, so I'm going to say take my linear here, say dot set hyperparameters. I need to specify the feature dimensions, how many features I'm going to use as an input. Because this is a very simple data set, I only have one feature, I only have one input, which is my number of years of experience. I need to specify the predictor type, and here I'm doing a regression task. I need to specify the mini batch size, which is simply how many data points that I'm going to feed into the algorithm at once. And here I'm going to use 5. I need to specify the epochs, how many epochs are going to run my model. Maybe I'm going to set it maybe to 50. And what SageMaker does, which is I really like, you can actually train multiple models in parallel, and you will be able to obtain the best model out of all of them. So here I'm going to say, okay, please go ahead, train 32 models for me. And I want as well to specify my loss to be an absolute loss. Please note, because here we're doing a regression task, absolute loss would work just great, okay? If you guys are doing classification, you can leverage other metrics such as precision, recall, or any other metrics such as F1 score, for example. All right, so now I'm pretty much ready to pass my training data from S3 to train my linear learner model. So I'm gonna say linear.fit. I'm gonna say go to my train, and basically here I specify the path or my location of my training data in S3, which is S3 train data, which is what I have here. Here I have my S3 train data. That's my path that I specified. And that's it. It's actually very simple. So I'm going to go ahead and run it, shift enter, and see what's going to happen. So as you guys can see, it's telling me starting the job. So it's starting the training job right now. And if you guys will notice that when you train algorithms in SageMaker, it takes much longer compared to, for example, if you do the training using sklearn, like locally, for example. Here it takes a little bit longer, and hang in there. I know it might sound a little bit frustrating in the beginning, but don't worry. The power is in the final outcome. You actually can deploy the endpoint much easier in SageMaker, and you can run a hyperparameters tuning job. I'm going to show you guys all the different features of SageMaker. So now I'm launching the requested ML instance. So that's what's happening in the background. And then you will find tons of, like data that starts to appear out of nowhere. And you will find as well all the details and information on pretty much every model, on all the 32 models that the SageMaker is training at the moment. So again, it's taking a little bit of while. Please hang in there and be patient. And actually, let's go ahead, and I want to show you guys the mini challenge first. So what I want you guys to do is to go ahead and try to train the model with more epochs and additional number of models as well. So maybe instead of having 50 epochs, try to maybe run it with, let's say, 200 epochs, for example, and see if the model performance is improved or not. And maybe try, instead of 32 models, maybe try more number of models. And what I want you guys as well to do afterwards is to try to reduce the cost of the billable seconds. Okay, you guys can need to do a little bit of quick search, try to see how can we do that. And so now we're preparing the instance for training. Okay, so let's wait. So again, it will take a little bit of while to actually train. So I'm gonna see you guys back. I'm gonna pause the video, and I will see you guys when the model is trained. All right, so I'm back. So it took, I would say, between 5 and maybe 7 minutes for the training job to be complete. So here you guys can see you start the training job, you launch the requested ML instance, you prepare the instance for training, you download the input data, and then you download the training image. And you will find that basically SageMaker spits out a ton of information. So there's tons of okay, it's actually like quite hard to read. It's not very readable. But what you could see here is that we have model. So you can see that there is model 0, there is model 1, model 2, and you keep moving forward, model 8, 9, 10, 12, 17. If you guys remember, we trained 32 models, so between 0 and 31, okay? And if you scroll down here, tons of information, we keep going. Again, tons of information. All what I'm looking for is the final metrics, and that's what we actually care about. Scroll down. Okay. So you guys will notice that here I have my mean squared error, so that's my MSE, and here I have my absolute loss of around 6,000 here. So that's kind of the performance coming out from my model, and I'm going to show you guys that we're going to take the best model and actually going to deploy it. So we're going to create an endpoint out of it and actually do the assessment on the testing data set. Okay, so if you guys notice here that the training seconds are 66 and the billable seconds are 66 as well. So we actually didn't save any money at all. And that's the topic for my mini challenge. What I want you guys to do, so please go ahead, train the model with maybe more epochs, an additional number of models. You guys can try that on your own. So I'm not going to be showing you guys that. Just go ahead and just change the number of epochs and the number of models and just retrain it, just run the cell. But what I wanted to show you is how to reduce the cost of the billable seconds. Okay, so please go ahead, maybe do a quick search, and I will see you guys after the challenge. All right, I hope you guys were able to figure out the challenge. What I ask you guys to do is to see if you can reduce the cost of the billable seconds. So what you guys could do is that you can come up here, okay, and add just 3 lines of code, and we'll do a massive magic for us. So what you guys can do here is that you can come here and you can add an additional line. So you can say train underscore use underscore spot underscore instances equals to true. I'm going to explain in a minute what do I mean by that. I'm going to say here train underscore max underscore run equals to, maybe set it to maybe 300. And here you can specify my train underscore max underscore weight maybe we can set it to maybe 600, for example. Okay. Okay, so what did I add here? So what I'm doing here is that I'm saying, okay, when you train the model, you can leverage or use what we call it spot instances. And spot instances are basically unused EC2 instances that are available for a much less price compared to what we call it the on-demand price. So if you don't use spot instances, then you are basically requesting an instance to work right now on demand. So you have to pay the price for it. However, you can leverage spot instances. Think of the spot instances as kind of, like when you're doing, let's say, in US, for example, or Canada, for instance, you can leverage, or you can kind of, like run, for example, let's say laundry at between, let's say 12 o'clock at night till, let's say 4 a.m. at a much cheaper price. Okay, so you can do that to just save money. It's kind of the same way here. Instead of using the on-demand price, you can actually use what we call it the spot instance, and you can be charged with the spot price, which is much lower compared to the on-demand instance. Okay, so what I'm doing here, I'm saying, okay, go ahead and train using the spot instance, set that to true, because the default is false. And I'm going to say train maximum run equals to 300. And this is simply the timeout in seconds for the training. And I'm going to say, okay, please go ahead and wait. So I'm going to say train maximum wait. So I want you to wait, and that will be the time that I will wait until the spot instance is available. After that, I'm just going to give up and just use what I have, and that will be 600 seconds. Okay, so let's go ahead and actually train it again. Let's press Shift Enter. Oops, it's telling me there is an error here. So it's telling me there is train use spot instances. Okay, so I forgot the S. It's supposed to be instances. Shift Enter, and here we go. So it will take a little bit of while until it trains. So I will pause the video and I will be back once the training is complete. All right, so I'm back. So as you guys can see, the training is complete. And now we have the training seconds were actually 37, but the billable seconds were only 7. So the managed spot training savings, so because you used or leveraged spot instances, you have been able to save 81.1%. Please note that this is serious money, like for a massive corporation who like maybe training like massive number of training instances with different experiments. This is a huge discount. So I highly recommend that you guys enable or activate the train use spot instances to make it true pretty much in every single algorithm to save a lot of money. Okay, all right, so that's all what I have for task number 7. I know it was quite long. For task number 8, we're going to learn how to deploy and test our trained linear learner model. So please stay tuned and please enjoy AWS SageMaker practical course, and I will see you guys in the next lecture.